Hello, my name is Simon, and today I'm going to present to you our SoK on multi-perspective video anonymization. This was done with Amar, Omar, Moured, and Thorsten Strufe. Sadly, Islam can't be here today because his visa was rejected, which is very sad because he's a first-year PhD student and this is his first accepted paper. So it would have been really nice if he were here. Thank you. For our motivation, why do we need multi-perspective video anonymization? Consider a scenario like in an operation room. When you have a single camera, this is nice. You can already observe what's happening. You can, for example, use this in medical practice to teach new doctors. But of course, this is limited because the camera can only see the whole procedure from one angle. And what you do is then you put up more cameras. And with this, you get a 360-degree coverage from all sides, and you get much more reliable tracking that you can use to, for example, also do 3D models of the persons and so on. And you can use all the views from all the cameras and fuse them together. Now, while this is a nice setup, it also brings us new privacy problems. So when we look at the biometric information contained in these scenarios, then for single view, for example, for the face, you can only see then half of the face. And for multi-view, of course, you get much more precise data. You can fuse the different views together to get a more accurate piece of data, which you can use for identification or for attribute inference. Same is also for the body. So usually, well, of course, if you just have someone from the back, you can't identify them. But since you have them from all sides, this works. Now, when we consider anonymization, then we have in the single view scenario, it's not so, it's actually quite simple. You just pick an anonymization and put it on the face, for example. Now, since this is video, you have to consider time consistency. So that, of course, if you anonymize one frame with a specific face, then the next frame should also look the same. So if the identity is changing all the time, that's not so nice. And in the multi-view perspective, you have the problem that you have to synchronize the anonymization. Because as seen in the picture below, when you then have two different anonymizations, for example, two different faces that you generated and put on the person, then this doesn't make any sense. And for example, if the face contains certain information, like sometimes you want to contain age or gender, then putting this together, it can also reveal more information than you want to reveal. And then further, you have the problem that if you forget one view and don't anonymize properly, then you run into the problem. Then, of course, all the other anonymizations are meaningless because as long as you have one view to identify, that's a problem. And now our contribution is that we looked at the current literature and did the first comprehensive survey on single and multi-perspective video anonymization. And we defined a taxonomy for the anonymization methods, which I will discuss later a bit in detail, but also for the targets and the utility objectives that you can have in this space. And we also analyzed the multi-perspective privacy threats and looked at the cross-camera leakage that you can have. Now, the methodology that we use for our survey is a Prisma surveying strategy using the words video anonymization and video de-identification. And with this, we got an initial seed of 414 papers in a time frame from 2011 to 2025, which we then filtered by looking into them more closely to see if they have a proper privacy evaluation and if they're, for example, peer-reviewed and so on. And after this filtering, we got a final corpus of 45 papers. Now, looking at these papers, for all of them, we looked at using our taxonomy, what do they use, how do they anonymize, what's the concept behind it. Then we looked at our multi-view camera scenario and found that most of them actually don't support this very well. We looked at the privacy metrics, the utility metrics, and of course the utility goals. So different anonymizations claim different goals that they want to achieve with their anonymization. So important to differentiate here. Now, for our taxonomy that we use to classify the different anonymization approaches, consider here an original image on the left. And then we split into two categories. The first one is called obfuscation. And obfuscation are all these techniques that use the information that's still that's already in the image and just perturb it in a way. So they keep the original information and then perturb it. And the first subcategory for this is a pixel level signal aggregation. So here we just take the pixels without looking at their semantic. And then one category is, for example, blurring, noise injection, and adversarial perturbation are also in this category. And the second subcategory for obfuscation is identity-aware isolation, in which the identity, so there we look at the semantic, essentially the identity information, and try to change them in a way that we can no longer identify that person. And then the second branch of our anonymizations are the substitution-based anonymizations. Here we completely replace the identifying information. For example, for the face, we simply generate a new one and replace the face that's there. And you can also do this for the full body and then have a full body anonymization. Now, looking a bit at the landscape, most techniques that we found in our survey are obfuscation-based methods, and then 35% of them focus mostly on the face, 15% only on the body, and identity isolation is only 5% of the corpus. And when we look a bit at the time scale, then we see that blurring, noise, and adversarial perturbations were quite early. Then some identity isolations appeared, and then the more newer anonymizations are then first GAN-based, and now the newest are usually diffusion models. And when we look at the target of the anonymizations, we see that 75% targets the face, and only 15% the body, and 10% gait, so behavior is often overlooked. Now, coming to the takeaways, we found that there's a lack of multi-view evaluation metrics, so there's no standard privacy and utility evaluation metrics for multi-perspective video anonymization. Then these methods often don't look at the temporal and cross-view consistency, so most methods just focus on single frames, and then you get artifacts if you anonymize a full video, like flickering. That's of course not nice, and also the cross-view consistency is not given. And our main takeaway is that we need holistic anonymization in this field, where we can jointly anonymize first all frames over the time, and then of course all views together, so that we get a consistent anonymization result. That would be already all. This is our paper. If you have more questions than I can answer, then feel free to reach out to Islam.